Okay, so another function that we have to work out the integral of, and that's our exponential function, e to the x, or e to the kx if you like. So all we need to be aware of is that in the same way that when we work out the derivative of e to the 3x, we differentiate that term and bring it out the front. So e to the 3x, the derivative of that is 3e to the 3x. Well, to work out the antiderivative, again, we don't touch the power. All we have is a 1 on k term out the front. All right. So if we work through some of these examples, the k term is -2. So the antiderivative of that is -1 on 2e to the minus 2x plus some constant c. All right. Something like b, it's 4 times e to the minus 2x with the negative k term out the front, plus, even if you like, the k term here is 3, so it's 1 on 3 times 2e to the 3x plus 2 plus some constant c. So tidy that up, we'll have a -2e to the minus 2x plus 2/3 e to the 3x plus 2. So it doesn't really matter about the fact that we've got a +2 or a -6 or a, any other term there in our exponential, because don't forget, all that's really doing is shifting our graph left and right. It's not changing the slope of our line in any way. All right. Antiderivative of e to the x on 4. So again, let's remember that's the same as e to the 1/4 of x minus 4x dx. So the antiderivative of that is 1 on 1/4 e to the 1/4 of x minus, add 1 to the power and divide, plus c, 4e to the x on 4, if we want to write it that way, minus 2x squared plus some constant c. All right. Last one there, we did one similar in terms of just having x and indices. Let's split it up. We don't have a quotient rule for integration, so that's the same as e to the 2x over e to the 3x, plus, if you like, the integral of negative e to the x over e to the 3x. Don't forget your dx's, Mr. Gale. So that's equal to the integral of e to the 2x and e to the 3x is e to the minus x, and e to the x on e to the 3x is negative e to the negative 2x. So if I work out those two derivatives, or antiderivatives I should say, I get minus 1 e to the minus x, minus a minus, I get minus negative a half e to the minus 2x plus some constant, which gives me, or positive a half minus, oops, a bit quick, e to the minus 2x minus e to the minus x. Just tidy up that negative sign. Plus some constant c. All right. Finally, let's have a look at example 9. Same thing, we've got a derivative, we've got to find the original function. So we know then that y is equal to the antiderivative of, I'll bring the 2 out the front, e to the 3x dx. So y is equal to 2 times 1 on k, e to the kx plus some constant. So I'll just say y is equal to 2/3 e to the 3x plus some c. So y is equal to 0 when x is equal to 1. So 0 is equal to 2/3 e to the 3 times 1 plus c. So c is equal to negative 2/3 e to the 3. So let's put that in. So we get y is equal to 2/3 e to the 3x minus 2/3 e to the 3. So we might possibly take that 2/3 out the front, e to the 3x minus e to the 3. All right, so we can't do anything with that. 2 to the power of 3 minus 2. It's not 2 to the, well, actually, that's a bad example. 3 to the power of 3 minus 3, okay, is not 3 to the 2, is it? 27 minus 3 does not equal 9. So we can't do anything with those just because they're the same base. Because they're not multiplying and dividing, we can't do a real lot with those. All right, so there's our answer.